Welcome to ECNG 3001 Group 4 podcast, where we discuss communication in a marine environment.
Fishing is one of the most dangerous occupations in the world. As a consequence of this, it was proposed to use M-Fisheries, a mobile application, to facilitate emergency communication. However, due to the lack of communications infrastructure, this has become a challenge. Thus, propagation principles and models were investigated and a communication link was designed. The first step in designing the link was assessing the intended operation environment, which was the marine environment. This describes an open space environment that has a highly refractive and reflective surface. There is also the effect of the Earth's curvature and thermal noise. Considering the characteristics of the marine environment, both the Longley Rice and the ITU model were suitable for the marine environment. However, a suitable model was selected, this being the ITU model, as it was suited to the environment, and its field strength curves catered to the ever-changing marine climate. The communication link was designed using Wi-Fi 802.11g and the following parameters. The maximum link length was determined using the practical limits: antenna height, receiver sensitivity, transmitter power and antenna gain, and the fundamental limit: free space path loss, all the while keeping the desired quantity and quality metrics for this application in mind. The quantity metrics refer to the transmitter power, antenna gain, receiver sensitivity, and losses. The gain and the transmitter power should be high to minimize path loss and ensure good signal reception while staying within the FCC regulations. Receiver sensitivity should be low, but should be modified according to the SNR to determine the minimum sensitivity at which an acceptable signal can be received. Quality metrics determine how well the data is interpreted at the receiver. For good performance of the link, we would want a high reliability, throughput, and SNR. However, we would want a low jitter, delay, and bit error rate. For this application, the bandwidth should be low as there would not be many users at sea. After link design, there was link simulation. Comparing the simulated values to the calculated values, any discrepancies discovered can be accounted for by the rounding of values and for the different methods utilized. It is recommended that the metrics can be reassessed for further optimization. The data rate of 6 megabytes per second can be used since the packet is relatively small, and more powerful routers with higher gains should be included to improve the quality metrics. The following are key considerations for designing a communication link. This includes the practical and fundamental limits during link design and the selection of a propagation model based on the type of environment required.